So sometimes a person wishes to borrow money from the bank, but can only afford to pay a certain fixed payment per month, which is usually smaller than a normal bank loan monthly repayment. So the bank will then need to determine the duration of the loan by finding out the number of fixed payments necessary to amortize that loan. So what we're looking at here are called fixed payment annuities. Now in the first part 1, we're going to look at determining the number of repayment periods using logarithms. Now if you think back to all our finance formulae that we've been using, N stands for the number of repayment periods, and our N is an exponent. Now, if you think back to doing your sectional logs, exponents and logs are directly related to one another. So we need an important log law to solve for the equations. And in essence, what it does is it gets that N out of being in the exponent to actually just being a coefficient. So what this log law says is that if I've got log of a power, that exponent can come to the front. You'll see there it is. And you multiply by the log of the same number. Right, so let's have a look at this example, which we're going to use in both parts. Okay, so in this example, we've got a loan of 300,000 Rand is to be repaid by means of monthly payments of 5,000 Rand, starting 1 month after the granting of the loan. It's quite important, 1 month after the granting of the loan. Interest is fixed as 18% per annum compounded monthly, and the question says determine the number of payments required to amortize the loan. So let's start with our timeline. There we go. There's the timeline. Now we know that we don't know our N, so we're going to start. We've got T0, T1, T2, all the way up to Tn. And let's just pop the 1 in before Tn minus 1. Okay, now we know that we've got a loan of 300,000. In other words, that's our present value. So let's put it over here. So remember that that's our present value. And we've got payments of 5,000 starting 1 month after the granting of the loan. So there's 5,000 all the way up to that end payment. Now we need to calculate that N, the number of payments. Let's just pop our interest rate in. We know that it is 18% and it's compounded monthly. Alright, so let's have a look. This is a present value formula. We're getting back to a present value of 300,000. So let's just extend this page a little bit. Okay, so we're getting back to a present value of 300,000. So our present value is 300,000. Then we've got our payments of 5,000. Popped into your present value formula, 1 minus 1 plus your interest rate, 0,18/12, to the negative N, and that N is what we don't know, divided by your interest rate. Okay. Right, so now we want to get to this N, so we need to solve for everything else around. Now, I'm going to do it in one step. I've got my 300,000. I can divide by 5,000 and then times by my interest rate. And that actually gives me an awesome, nice number of 0,9. But if it is an ugly decimal, just store it in your calculator. And that's equal to 1 minus all this stuff here, which I can actually work out to be 1,015. That is to the power of negative N. Okay, so we're getting closer. We want to get this on its own. So I'm going to add it, and then I'm going to go 1 minus 0,9. So I've got 1,015 to the negative n. 1 minus 0,9 gives me 0,1. Great. All right, so now I've got that exponential equation that I can use that log law on. So I'm going to show you every step, but you can definitely leave out some of these steps in future. Let's put a log, take the log on both sides. So I've got log of 1,015 to the negative n is equal to log of 0,1. Still equivalent because I'm taking the log of both sides. Now remember the law says that my exponent can come to the front, so I've got negative n log 1,015 is equal to log 0,1. Now, to get that negative n on its own, I've got log 0,1 divided by log 1,015. So I get negative n is equal to, now don't round off, negative 154,654,1086. But I don't want a negative n, I want a positive n, so my n is equal to 154,654,1086. Cool, so I've got what my n is. So let's answer our question. Remember the question said to determine the number of payments required to amortize the loan. So what we've got from this is that there are, look for your whole number, 154 monthly payments, and that's of the amount of 5,000 Rand that was given to us. But we also have, so, and a final payment, which is less, that's what the decimal means, it's less than 5,000 Rand. So in total we actually have 155 payments, but that last one is less than 5,000 Rand. And in the next video, part 2, we're going to look at how to find out what that actual final payment is.